Hello, everybody. We are back with another visual pattern challenge for you. Here is step one of today's pattern. Here's step two. Here's step three. Your challenge would be to predict the number of cylinders in step four. And if you can do that, how many in step 43? And can you write an equation that you could use to predict the number of cylinders in any step at all? So if you'd like to accept that challenge, pause the video and give it a try. All right. So let's just look at this and see if we can gain some intuition about it. What I see is a group of cylinders that's getting much bigger really quickly. So my first thought is maybe this is not linear. Maybe this is quadratic or something else because it's expanding really rapidly. And I think we're going to end up with a pretty big number in step 43. Um, Maybe we should try to predict step four just by seeing what patterns are here. um, what I'm noticing is that there are an increasing number of rows, right? So we have 3 rows and then 4 rows and then 5 rows. So I'm guessing there are going to be 6 rows here in step 4. And then the rows themselves, they increase by 1 every time. So this is 3 rows of 2 and then 4 rows of 3 and then 5 rows of 4. So these must be 6 rows of 5. So 6 times 5 would be 30. So I think there are going to be 30 in the next step. Well, let's take a minute to just analyze the numbers carefully. So we'll make a chart here with the step number and the number of cylinders. So in step 1, we've got 6, 2 rows of 3. In step 2, we've got 3 rows of 2. In step 2, we've got 4 rows of 3, so that'd be 12. Wow, that doubles. Goodness. And in step 3, we've got 5 rows of 4, so that'd be 20. Okay, not quite doubling. And in step 4, we're predicting 30. So let's go ahead and take the difference between each step so we can see how much it's going up each step. So 12 minus 6 is 6, 20 minus 12 is 8, 30 minus 20 is 10. So this set of differences is not a constant number, which means it's not a linear pattern. When that happens, we like to take the second set of differences, the difference of the differences. 8 minus 6 is 2, 10 minus 8 is 2. And if we get a constant there, we know that this is a quadratic somehow. So there's an x squared involved in here. So I think since there's an x squared, I'm going to go back to the pattern and try to outline squares and see what that brings me. So here is a 2 by 2 square and then a leftover row. And here is a 3 by 3 square with a leftover row. And here is a 4 by 4 square with a leftover row. So that looks pretty promising because I think I can write an equation based on this visual intuition. Here we have a 2 by 2 square. That's the step number plus 1 squared. So that would be x plus 1 squared. And then we have a row of 2. Well, that's the step number plus 1. So plus x plus 1. Now let's see how that works in the other steps. Here is a 3 by 3 square. So that's the step number plus 1. 2 plus 1 would be 3 squared. And then a row of 3, that would be the step number 2 plus 1. So yeah, that seems to work. Let's actually plug the numbers in this equation. So we have y equals the step number plus 1 squared plus the step number plus 1. So 1 plus 1 is 2 squared is 4 plus 1 plus 1, that'd be 6. Yes, that checks out. Here we'd have 2 plus 1 quantity squared plus the step number plus 1. So that'd be 3 squared, 9 plus 3. Yeah, that's what we've got here. We've got 12. Let's try it with step 3 just to be sure. So we'd have step 3 plus 1 quantity squared plus the step number plus 1. And 3 plus 1 would be 4. That'd be 16 plus 4 more would be 20. Yeah, that's what we're getting. So this looks to work. I'm going to FOIL this out and see if I can simplify this at all. So x plus 1 squared would be x squared plus 2x plus 1. And then we have a plus x and a plus 1. So that would be x squared plus 3x plus 2. So that equation, after I've FOILed it out and combined the like terms, is that right? Yeah, that looks right. That will be an equation that you could use to predict any step at all here. You could keep it in this form if you want. I mean, this form has some advantages because it really shows visually what's going on here, but this form is a little simpler just in the algebra. But let's go ahead and figure out how many in step 43. So what I would do here is I would plug in step 43, number 43 for x. So this is going to be 43 squared plus 3 times 43 plus that 2. So let me pull out a calculator here so I don't mess this up. So 43 squared is 1,849 plus 3 times 43. So 3 times 40 is 120, so that's 129. And then plus another 2. So 18, that's 20, and that's 8 and 9. I'm getting 1,980. Let me know if you got the same thing. Did this work out for you? Did you see the pattern like this? Did you come up with that equation? I'd like to know. Thanks, everybody.